Okay, so let's talk about using voltages digitally. And you know, in some ways, how hard can this be? And it's interesting to think a little bit about that. Suppose we had a range of voltages. And again, for the sake of argument, here's voltage. We'll have 1 volt at this end and 0 volts at that end. And what I want to do is to map them onto bits. So this is volts. Okay, and here I have bits. So this will be 0, the bit 0. And let's say up here will be the bit 1. And what I want to do is to produce a little chart that tells you for each voltage what the corresponding bit is. Now it's very tempting to say, look, let's pick a threshold voltage in the middle here. Okay, some sort of threshold voltage. And why do I want to make everything less than the threshold voltage, or less than or equal to the threshold voltage, be a 0, and everything that's strictly greater than the threshold voltage be 1? Now, if you're a programmer or a mathematician, you're probably saying to yourself, what? Gets the job done, right? I can write a program to do this. You know, mathematics, this is a very clear, complete, no overlap. Why as an engineer would this bother you? Yes?
Because the error that exists there in the middle would shift you to the other side pretty quickly.
Right. I think so the idea is that if we can measure things very, very, very precisely, very, very, very quickly, this is okay. But maybe in the real world, you know, sort of distinguishing between 0.4999 volts and 0.5001 volts is a tricky business, particularly if you have to do it within a billionth of a second. Okay, so the idea here is that these two voltages, by this definition, are very clear. Okay, in terms of I mean, I can tell you precisely how to map them. The difficulty is it's very hard to build a machine that is both inexpensive, can be manufactured, you know, inexpensively, and gets the job done quickly, because as I get closer and closer to this threshold, that job becomes harder and harder and harder. So this is an example of a phenomenon that we're going to meet a couple times in the course. The engineering problem of mapping a continuous variable to a discrete variable is really thorny. And in fact, we can't do it. Okay, you know, we'll make mathematical arguments a little later why we're going to get ourselves into trouble. But right at the moment, just sort of intuitively, just imagine that it becomes harder and harder and harder as I get closer and closer and closer to the threshold, to the point that it exceeds our ability to get the job done. So whenever somebody gives you sort of a continuous phenomenon and says, map this into fish or not fish, or map this into, you know, whatever it is, okay, there'll be cases that you have to deal with, and the way you deal with it on an engineering basis, that are very hard to deal with, the way you deal with it on an engineering basis is that we're going to introduce, okay, this notion of a forbidden zone. So notice what I did. I completely wiped out the middle of the graph. And what I'm going to do is to say voltages that are less than some threshold voltage here. Now I'm going to call this the low threshold. And are 0, and voltages greater than the high threshold are 1. But there's a range of voltages in the middle here, okay, in which is absolutely uninterpreted. Right? You cannot ask our system what is the voltage that's somewhere in here. You can't ask it whether it's 0 or 1. The system is allowed to never give you an answer, to do all sorts of weird things. Okay? Basically, when we're engineering a digital system, we'll only require it to work when signals are in the less than VL or greater than VH. And if we put that forbidden zone in there, a region where we don't have it's not a complete mapping now between the continuous voltage and the discrete 0 and 1, we're going to leave out a portion of that mapping, and that will actually make everything. Now we can suddenly build, you know, computers that I can sell you for you know, a couple $100. Yes, sir, ma'am. Sorry.
Why is it any easier to measure up to VL and VH than it is?
Right. You can sort of say, well, suppose if I had to do this. Okay, why is it, you know, is it measuring the threshold somehow easier or harder than measuring up to VL? And the answer is that I can build a system that basically has, you know, a really sloppy threshold somewhere in the middle. Okay, it only has to get the right answer when it's less than VL. It might produce other answers in here, but it's not required to. In other words, I can build a very inexpensive system that can tell you whether a voltage is less than a quarter of a volt, okay, by having some sort of, simple resistor divider and an op amp or something that's working somewhere around the half-volt range. In other words, I've left myself room for all sorts of bad things to happen. I'm only required to get the right answer here. So this unknown area, okay, this is a lack of specification. This isn't a requirement that the system do nothing. There's no requirement at all. Yes?
Going back to the picture as well, that picture had ranges of voltages. What happens if you have, say, some sort of signal or image where all the voltages are within that forbidden zone? There's no way to translate into digital signal.
Right, so you're going back to saying, well, how does this help us encode the picture? Right, this representation. And the answer is we're going to have to go through a different process of encoding the picture. And some of that process will involve a slightly sloppy interpretation of a luminosity into a series of bits, a so-called A to D converter, analog to digital converter. And depending on how much money you spend, you can get highly accurate ones or less accurate ones if you only want a cheap thing. So, but once you've done that, it's this specification that we'll use to represent the bits themselves. Does that make sense? Okay, so I haven't actually answered the question of how to encode pictures yet. We probably won't get to that in this course, but that's an interesting question, and actually one I spent 10 years of my life working on. Back when we started first getting digital video, I built a lot of chips to do digital video manipulation. So, other questions or issues people have? Okay, well, we have some brave people who can raise their hands. I hope you all do that. So now we have this notion of valid and invalid logic symbols.